Pedro Domingos, The Master Algorithm, How the Quest for the Ultimate Learning Machine Will Remake Our World. Embark on a journey to discover the world of algorithms and their incredible potential in The Master Algorithm, How the Quest for the Ultimate Learning Machine Will Remake Our World. This book by Pedro Domingos unveils the fascinating realm of machine learning algorithms and their diverse applications, from deciphering handwriting to making medical diagnoses. Learn how these versatile algorithms can solve seemingly unrelated problems and how they revolutionize various aspects of our lives. Uncover the importance of avoiding overfitting, dive into the Bayesian inference, explore unsupervised learning, and envision the ultimate master learning algorithm that could shape our future.
The power of algorithms. Algorithms are a series of precise instructions that produce the same result every time, and their application is widespread. Machine learning, ML, algorithms are even more powerful, as they can output algorithms themselves. This makes them useful for solving difficult problems that human programmers may not be able to put into words, such as deciphering handwriting. By providing the ML algorithm with lots of examples of handwritten text and its meaning, it can produce an algorithm that can transform the former into the latter. The great thing about ML algorithms is that they can be applied to many different problems with the same underlying algorithm but different datasets. For example, making a medical diagnosis, filtering spam, and finding the best chess move only require one ML algorithm and the appropriate data. Hallucinations in machine learning. Understanding overfitting and the importance of holdout data in algorithmic models. In the world of machine learning algorithms, hallucinations take the form of patterns that arise as a result of overfitting. Overfitting occurs when an algorithm is given too much power to learn from data, resulting in complex models that are unable to generalize beyond the given data set. To prevent this, ML experts need to impose limits that restrict the algorithm's scope and complexity, ensuring its results are verifiable and consistent. One way to do this is by dividing the data set into a training set for learning and a holdout set for testing. The holdout data allows for double-checking the results and confirming the validity of the patterns found in the data. As a result, ML experts must ensure that the rules of the algorithm are not too flexible and that results perform well against both the training set data and the holdout set data. Overall, understanding the importance of avoiding hallucinations and using methods like holdout data can help optimize algorithmic models in machine learning. Controlling the power of algorithms. In the world of algorithms, hallucinating patterns is a prevalent problem known as overfitting. Overfitting happens when an algorithm is so powerful that it can learn anything, leading to the creation of complex models that are only valid for specific data sets. To avoid this problem, algorithms must have limitations on their complexity to ensure that their results are consistent and verifiable. The solution is to use holdout data, which is a set of data to test the algorithm's validity. Machine learning experts' job is to ensure that the algorithm's power is restricted by making sure the rules are not too flexible and that the results perform well against both the training set and the holdout set. Intelligent observation. Bayesianism is a popular branch of machine learning that focuses on empirical evidence to improve logical reasoning. Unlike rationalists, Bayesians believe in observing and experimenting to acquire true intelligence. Their favored algorithm, Bayesian inference, simultaneously retains multiple models or hypotheses and assesses the evidence for each. This algorithm helps in providing medical diagnoses by sifting through patient data to find the best fit. Bayesian inference prevents overfitting by restricting assumptions about cause and effect relations between different events. The algorithm achieves its remarkable accuracy in voice recognition and other applications by considering the frequency of how often certain words appear in sequence. Bayesianism is a powerful technique to improve decision-making by taking into account all available evidence. Mastering the art of unsupervised learning. Our ability to filter and focus on specific auditory information has inspired the development of unsupervised learning algorithms. Unlike supervised learning algorithms that require labeled examples to learn from, unsupervised learning algorithms process raw and noisy data to discover categories and meaningful structures. Clustering algorithms are a prime example of this and are used in image recognition and voice isolation software. These algorithms reduce the dimensionality of data to its primary essentials. Neural networks, on the other hand, work like a brain and process multiple inputs simultaneously. One neural network was even able to sift through 10 million randomly selected YouTube videos to recognize human faces and cats without being told what to look for. The combination of these different algorithms could lead to the creation of a master algorithm. One algorithm to rule them all. Algorithms can solve a wide range of problems, but the key is to make the right assumptions about the data being applied to. While many difficult problems in computer science can be solved with one good algorithm, the most important problems require much more capable algorithms than are currently available. However, progress is being made, such as with Adam, a research robot that can suggest hypotheses and carry out experiments in biology. Do you ever wonder which algorithm is the best for a given problem? The truth is, there is no perfect algorithm as they all rely on different fundamental assumptions. Even for a data set where an algorithm comes up with something useful, a devil's advocate could use the same algorithm on another data set to prove that everything it does is nonsensical. However, the good news is that most of the most difficult problems in computer science are fundamentally related and can be solved with one good algorithm. These problems include determining the shortest route to visit several cities, compressing data, controlling urban traffic flow, turning 2D images into 3D shapes, laying out components on a microchip, and even playing Tetris. In essence, finding an efficient solution to one of these problems can solve them all. This insight is considered one of the most fascinating in all of computer science. But unfortunately, the most important problems facing humanity, such as finding a cure for cancer, require much more sophisticated algorithms than what we currently have. Progress is being made, however, with robots like Adam at the Institute of Biology in Manchester. Adam has learned general knowledge about genetics and can suggest hypotheses, design and conduct experiments, test and analyze their results. While the ultimate algorithm to address the most significant issues is beyond the technology we have today, we are making strides towards it. The power of data. In the world of big business, data is the new oil. The company with the best algorithms tops the list. Machine learning helps in narrowing down the choices for consumers. Amazon tops the game of providing intelligent suggestions to customers. The race is still on, and whoever has the best data wins. The buying and selling of data have become so big that experts believe the future will have data unions and data banks. The regulation of data usage can benefit businesses and individuals, it can enhance algorithms, personalize purchase recommendations, and raise the level of security. Your digital self, the ultimate personal butler. The future is here, and it's bringing a digital version of yourself. By feeding all your data to an ultimate master learning algorithm, it will create a personalized model of yourself that can act as your personal butler. From filing your taxes to finding your perfect job, your digital self can handle all the little annoyances in your life. In a world where digital models are a common thing, having a digital butler could save you both time and effort, making your life much easier.
In conclusion, the master algorithm reveals how machine learning algorithms have become an indispensable part of our world, powering multiple aspects of technology and business. With their ability to learn from examples and adapt to various tasks, these algorithms showcase immense potential. From solving complex problems to revolutionizing personalized suggestions in the world of online shopping, machine learning continues to advance at a rapid pace. Furthermore, the vision of a master learning algorithm to create digital models of ourselves could transform our interactions with the digital world and even with each other. This book enlightens us on the importance of understanding the power and limitations of these algorithms, and guides us through this exciting journey of technological advancements.